Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Welcome to the Environmental Chemistry course. This is the third meeting today. We will talk about the chemical process in atmospheric environment. Today with me, Adri Huda. This is the following course from our previous course related to the water, chemistry of water. In the first meeting, the second meeting, we will focus on water contamination pathways. And now we will talk mostly about the chemical process in an atmospheric environment. In the beginning, in the first meeting, we will talk about how the water, from the perspective of chemistry, the molecular formation and the properties of the water. Second, we'll talk about how the contamination could react with water itself and then destroy the purity of water. And today we will mostly talk about the chemical process in the atmospheric environment, where we mostly talk about the water in the gases phase. Let me begin with a brief introduction about the air pollution and water contamination. Here in the atmospheric system, it's also in the atmospheric system also played an important role in the water contamination process, where the contamination itself is not related to the water in the atmosphere, but the reaction between water and the pollution, especially the gas pollution, could form the a specific substances that can contribute in water pollution. In the beginning, I will mention four most reported chemical reaction occurred in the atmospheric system, which is the photochemical processes. The second one is the oxidation reaction, and the third one is free radical reaction, and then we close with the acid-base reaction. As we can see here on the slide, that we could see that there is a lot of things occur in the atmospheric system. There is aerosol, precipitation, fog droplets, and then there is a lot of activities that could contribute in the distribution of pollution in the atmospheric system. For example, the natural disaster, the volcanic ash, biomass burning smoke, the industrialization, the urbanization, where there's a lot of urban area that could produce the gases on the atmospheric. Let me begin with the photochemical processes, where it stands with photo and chemical, which mean that there is a certain of like a reaction, chemical reaction that initiated by the light irradiation or photo. It means the photo mean that light irradiation. Photochemical processes uses light as an initiator to start the chemical processes. And it means that without light, there is no chemical reaction in this term. So the light itself initiate the reaction by providing the energy amount, a certain amount of energy to start the chemical reaction. One of the most well-known photochemical reaction or photochemical process in the atmospheric system is called Chapman cycle, which means that the formation and the deformation of ozone molecules. As we know that in the atmospheric system, we have the oxygen, and then the number of oxygen in the atmospheric varies in typically of the area. But if we talk about the oxygen alone, that the oxygen can be split by light irradiation. And then this reaction of the splitting of oxygen is called the photochemical reaction. Um, some studies report that the wavelength less than 242 nanometer irradiated by a certain type of UV light could split the oxygen to form two oxygen radical. And then those two oxygen radical, when they meet the other oxygen, they can make a reaction between the oxygen radical and oxygen to form the ozone molecule, or as we know, the O3 molecule. And the O3 molecule, if they got irradiated again by light irradiation, a certain type of UV light with a specific light wavelength around 320 nanometer, the ozone molecule can get split again to form the oxygen and the oxygen radicals. The way of the oxygen splitting between the oxygen molecule to form the oxygen radical, it's called free radical reaction. Free radical formation, sorry. And then the reaction between the oxygen radical with the oxygen to form the ozone molecule is called free radical reaction. As we mentioned before in the beginning, that in the atmospheric system, there's photochemical reaction, which means that the oxygen get irradiated, but the light, it's called photochemical reaction. And then they form two radical oxygen. And then when the two radical oxygen react with the other oxygen, they start to make the free radical reaction to form the ozone molecules. And then when the ozone molecule hit with the other compounds, for example, here, as we can see here, there is a VOC or volatile organic compounds. It could be a pollutant, carbon dioxide, carbon monoxide, methanes, and etc. And then when they hit with ozone that form from the free radical reaction, they could start making the other product. For example, here, hydroxyl ion, they can form the carbon oxide-based molecule. And then, for example, the hydroxyl ion, when they hit by the other UV light, they can form a lot of things. For example, the HO2, and then when it get hits again, they can like form the other counterpart of molecules. Talking about VOC here, when they got react or they get they make a chemical reaction with the ozone molecule, they can form RO2. RO2 is typically the oxide product of the volatile organic carbon. And then when they got a reaction again with the ozone molecule, they can form the oxide form of volatile organic carbons. Basically, when the volatile organic carbon or VOC make a reaction with the ozone molecule, they could degrade, or as we know as an oxidation reaction. So the volatile organic carbon get oxidized by the presence of ozone molecule. It means that the volatile organic carbon get oxidized to form the oxidized volatile organic carbons. And then basically the degradation because of the oxidation reaction normally form the safer molecules or simple molecules that's safe for the atmospheric system. So we already mentioned about photochemical reaction where the reaction occur by the photo light irradiation. We already mentioned about free radical reaction where the oxygen radical produced from photochemical get react with the other substances. For example, the oxygen molecule, and then we also mentioned about the oxidation process where the ozone molecules get react with the other substances. Now we jump to the acid-base reaction.